So here's a question that is asking you to convert this trans 1-chloro-2-methyl cyclohexane from this representation to the chair conformation, to another representation. Once again, this is called representational competence. So meaning that you need to be able to translate back and forth between these different representations. The first thing you need to do is remember how this representation portrays information or provides you information. If you look at this cyclohexane ring, it's in the plane of the paper. And chlorine is coming out towards you. And methyl is going away from you. We agreed on that on the last page. Now, what we need to do when we actually draw the chair conformation is actually look at it slightly different. Imagine this is now on the floor. It's like a piece of paper thrown on the floor, whatever it is, and you're looking at it from the top. How would Cl look like? Or this bond, this CCl bond look like? Would it be away, up, down? What is it? It would be up. And this would be down. So then let's actually translate this into again, we don't expect perfection here. I can't even draw it properly on using this. Not a great way. Let me try it again. Just be patient with me again. It's not easy using this technology versus just using a pen and a paper. So again, here it is. Okay, we can just slow it down here. No. All right, let me just do one simple move right here. Is that just extend this up. Again, on your pencil, using your pencil and paper, it should look better. So this is roughly a good way. No need to worry about drawing it perfectly. So if we start numbering this would be 1, this would be 2, 3, 4, 5, and 6. Remember, the chloro gets number 1, alphabetical order. And let's say this is carbon 1 right here, because we need to look at the direction correctly. And this is carbon 2. Well, again, if we're looking at it from the top, and you're trying to show the Cl on 1, remember you have 2 bonds. You have the axial, which is going down, and then you have the equatorial, which is going up to the side here, near the equator. Like I said, the equator, around the equator. So if you put Cl down, it would contradict this right there. So the only way you can do it is, again, by putting it up with an equatorial position. Of course, there's an H that we don't show, but here it is. Now let's go to the Cl, the CH3. So the CH3 now is moving away from you. So if it's going away from you and it's down, if you put it at the axial position, once again, it will contradict. Once again, here's your I right here. You see the Cl kind of moving up and the CH3 is moving down. So then that would be an equatorial position. And this is the perfect position because you have now both equatorial. So we say both groups in the equatorial positions, which is much more favored than, of course, at any axial position. So this would be the most stable. again, it eliminates this diaxial as we talked about above here, the diaxial strain or the interaction right here. Very well.